Welcome to Maths and Science by IITian channel. In today's lecture, I will be taking up a typical function where the function is not directly defined in terms of x. It is defined for the values of n. Function x is equal to 1 by 2n plus 1, where x varies from 1 by 2n plus 2 to 1 by 2n plus 1. Then we have to find an integral for the function x dx, where x variable ranging from 0 to 1. Here the limits of x are given 0 to 1, but function x is not defined in terms of x. Function x is defined in terms of n, and x is also defined in terms of n, the range of the x. Then how to find out the integral of a function which is not function x, which is not in terms of x? It is related to something else. It's a very tricky and important problem to solve, and it's a challenging problem. It's a challenging problem on functions, useful for higher examinations, mathematical examinations like IIT JEE Advanced, IIT JEE Mains, and also CSIR-NET, and also for Maths Olympiad. It's a very typical problem where the function x is not straightforward and function x is not given in terms of x, and we have to find the function x dx integral, x varying from 0 to 1. Let us try to understand the concept behind it. I will explain the concepts, I will solve this problem, but if this type of problems do come, please apply the concepts and do better in the examinations. We will move forward. What is given in the question? Function x is equal to 1 by 2n plus 1, and x is varying between 2n plus 2 is less than x is less than 1 by 2n plus 1. This is the range of x. This is the value of function x. What we have to find? Find integral 0 to 1 function x dx. If function x is in terms of x, we can directly apply it, integral rules, and we can find out. In this case, what to be done? In this case, what is to be done? Let us please try to understand the concept. Let us take what is to be found. 0 to 1 function x dx integral. What is integral? The concept of integral is sum. Integral is equal to sum. What is differentiation? Differentiation is division. We are dividing something, and in integration we are adding something. This is the main concept. And how function x is defined? Let us try to write like this. Function x is defined as 1 by 2n plus 1. What we wanted? Dx. Function x, I have just replaced the value of function x as 1 by 2n plus 1 dx. Here, what I am required to find? Please try to understand the concept clearly. What I am required to find is, it is a sum. First, that is the first concept. What I am required to find? What is this value? Here for function x, in terms of x, it is 0 to 1. But function x is not in terms of x. It is in terms of n. Then I have to modify this value. When I am writing function x, replacing function x in terms of n. What is the lower limit? What is the upper limit? These two I have to define. For x, it is given, the lower limit is lower limit of x is equal to 1 by 2n plus 2. What is upper limit? Please try to understand the concept first. Don't worry about the answer. That, let us step by step, let us go. 0 to 1, because it's not a simple example in terms of x. This can be written as, shall I replace the limit of lower limit of x and upper limit of x in the, when I replace function x by 1 by 2n plus 1 dx, I will keep it as it is. Let us see. Step by step we will move. Lower limit, how much shall I write? I will write the lower limit of 1 by 2n plus 2. Upper limit is 1 by 2n plus 1. I think up to this you might have understood. And here you should not miss that it is not the only integral. It should be a sum. To be a sum. Because integration is sum. Then it is to be written as, because in terms of n we have written sigma. What is the, what you call symbol for sum? N is equal to 0 to n is equal to infinity sigma. Because n we are taking in terms of n. Then this is integral 1 by 2n plus 2 to 1 by 2n plus 1. 1 by 2n plus 1 dx. Hence, how we can write? Please try to understand. If this type of question is given, function x dx can be written as sigma n is equal to 0 to infinity integral 1 by 2n plus 2 to 1 by 2n plus 1 and 1 by 2n plus 1 dx. XOR is from 1 by 2n plus 2 to 1 by 2n plus 1. Now let us do the regular integral. Hence, it will be equal to that 1 by 2n plus 1, let me take it out, it is a constant, sigma, because I have taken sigma, n is equal to 0 to infinity, 1 by 2n plus 1, I will put it as same, and the x limits are 1 by 2n plus 2 and 1 by 2n plus 1 dx. What is the integral dx? Is equal to x. Please remember this. Integral of 1 dx is equal to x. Then this will be equal to sigma. Sigma will not change because we are taking the sum. Please try to understand, integral is a sum. Because it is in terms of n, we are taking n value from 0 to infinity. Into x, lower limit is 1 by 2n plus 2, 1 by 2n plus That means we have integrated and we got the value in terms of n. That is equal to sigma n is equal to 0 to infinity. The answer is 1 by 2n plus 1 into 1 by 2n plus 1 minus 1 by 2n plus 2. Do you agree? Upper limit and lower limit I have applied. Hence, int we have found out the integral value in terms of n as a sum of n varying from 0 to infinity, because function x is given in terms of n. Therefore, integral 0 to 1 function x dx is equal to into sum n is equal to 0 to infinity. Let us open the bracket. 1 by 2n plus 1 whole square minus sum n is equal to 0 to infinity 1 by 2n plus 1 into 1 by 2n plus 2. Do you agree? Just I opened the bracket. We know from my previous lectures 1 by 2n plus 1 whole square from 0 to infinity is pi square by 8. Please refer to my previous 2 lectures on functions, sequence and series. These are all standard series and sequence, which I have already proved that n is equal to 0 to infinity, sum of 1 by 2n plus 1 whole square is equal to pi square by 8. This is ln2. These two are already proved in my previous lecture on sequence and series. Please refer to them, and hence the value is equal to pi square by 8 minus ln2. Here the process is more important, converting the limits from 0 to 1 to in terms of n and converting function x in terms of n, converting the limits and then applying the regular integral and finding it, and after finding that integral, applying the sum of n is equal to 0 to infinity and finding the series sum. It is a combination of integrals, Riemann integrals, and also sequence and series. It's a very good example for finding the integral of a sequence and series as a sum of sequence and series, the value of integral as a sum of sequence and series, and finding its value. Hence, if this video has added some value to your knowledge, please kindly share and subscribe to my channel Maths and Science by IITian. And this is a very tricky problem. If you want to see it twice, don't worry for the value of pi square by 8 and ln2. These are all standard sequence and series values, but coupling these with integration is the trick that you try to understand. Try to understand that concept. Because in the higher mathematics like JEE Mains, JEE Advanced or Maths Olympiad, on a single straightforward way the questions will not be asked. There will be combination of 2-3 concepts. Here the concept of sequence and series is explained, here the concept of definite integrals is explained, and here also the process of combining series and sequence with integration is also explained. Best of luck to everybody. Thank you for listening to me. Thank you for viewing my lecture. Kindly share and subscribe to my channel Maths and Science by IITian. This type of problems I will be continuing and giving to you so that you will get more and more applications in mathematics, knowledge of applications in mathematics, and more concepts get cleared. Thank you.